Dear students, good morning. Let's start our first lesson in Unit 1. But before starting, let's see this video.
Oh, see here what the gardener is doing.
He's trying to move a big stone with a rod.
Yes, this rod is called liver.
Oh, liver?
Yes, let me show you its different parts.
Liver? Hey, it is fixed at one point.
Yes, the fixed part is called fulcrum. And see, he's putting force with his hands. It is called effort.
What is stone called here?
Oh, it is called the load. Do you know there are many kind of livers?
Many types of liver?
Yes, see, fulcrum is on center here. And see here.
Oh, effort here is by the person.
Yes, but fulcrum is on the other side and load is in the center.
Yes, in first one, fulcrum was on the other side. And here, it is in the center.
Let me show you one more type.
Oh, here effort is in the center.
Yes, load is on one side and fulcrum is on the other side. Let's see one more kind of lever. Now, can you tell me where's the fulcrum on this simple machine?
Oh yes, it is the center. It is fixed.
And where the effort is put?
Effort is put from the back and load is on the front.
Excellent. So from this movie, I'm sure you have learned some new vocabulary, some new words. So you know that our first lesson is about what we call levers. What is a lever? Levers are simple machines that we use in our daily life. Why do we use them? We use them to help us to perform heavy tasks more easily. And an example of the levers or simple machines are a wheelbarrow, a nut cracker, and a seesaw. These are examples of simple machines called levers. So, what is a lever? A lever is a rigid bar, straight or curved, which rotates around a fixed point called fulcrum. You have all noticed the fulcrum in the movie. And it is affected by an effort force and a resistance. The symbol of the fulcrum is O. The effort force is F and resistance is R. So now we know all what is the meaning of a lever, which are simple machines that we use to help us in our daily lives. Any lever consists of three main parts, which are first, the resistance. The resistance results from the weight of the body we want to move. Resistance is resulted from the weight of the body we want to move. An effort force, which is the force exerted by the person against this resistance force. And finally, the fulcrum. The fulcrum O, it's the fixed point where the rigid bar rotates. This is how we represent any lever. We said it's a rigid bar that rotates around a fixed point called fulcrum and affected by an effort force, the force that the person exerts, and a resistance. So the three main parts of the lever are the resistance, the effort force, and the fulcrum. Now, why do we use levers? We said we use levers to help us to perform tasks more easily. But we have some other importances. Let's check them one by one. First importance is increase in force. Increase in force. What is the meaning of increase in force? It means we exert a small force to get a great effort. We exert a small force to get a great effort. So the lever increases our force. Like what? Examples like the nutcracker. The nutcracker is a simple machine that we use to cut nuts. A bottle opener. So these are examples of levers that increases our force. Number 2, increasing the distance. Increasing the distance like the wheelbarrow, the manual broom. The manual broom is used to increase the distance. Why do we use the manual broom to increase the distance? Because we exert a force for a small distance up and the body moves from down of the manual broom. Importance number 3, increasing speed, like the hockey bat. The hockey bat is a lever that increases the speed of the ball. Number 4, moving force from one place to another. The example is the manual broom. It moves the force from where we touch or we hold the manual broom, and it moves the body on the ground, so we don't need to bend. So it moves the force from one place to another. Accuracy in performance. The doctors and watchmakers need to pick up small things. So what do they use? They will use tweezers. They use tweezers to pick some very small screws or things. So tweezers are used in accuracy in performance to pick up small things. Avoiding danger. Importance number 6. Can we hold coal by our naked hands or eyes for a long time? No, we can't. So that's why we use levers like coal holder or ice holder to avoid danger. So these are the 6 importances of levers. Increase in force, increase in distance, increase in speed, move in force from one place to another, accuracy in performance, and avoiding dangers. Now, the name of the lesson is the types of levers. Levers are classified according to the position of the fulcrum, the effort force, and the resistance. The position of the fulcrum, the resistance, and the effort force. And you noticed in the movie, each time we have the fulcrum, the resistance, and the effort force in different places or positions. That's why the levers are classified into 3 types of levers. Let's start by the first class, which is called the first class levers. They are the most popular levers in our daily life. We use them the most in our daily life. What is special about the first class levers? They have the fulcrum between the effort force and the resistance. They have the fulcrum between the effort force and the resistance. Examples of the first class levers: the seesaw, the crowbar, suction pump, scissors, balance, nail clipper. All these are examples of the first class lever. Why do we call them first class levers, or why do we classify them into first class levers? Because all of them have the fulcrum between the effort force and the resistance. In all these examples, you have the fulcrum between the effort force and the resistance. So the first class levers are levers having the fulcrum between the resistance and the effort force. What about the second class levers? The second class levers have the resistance between the fulcrum and the effort force. The resistance between the fulcrum and the effort force. So we represent them by a rigid bar and the resistance between the effort force and the fulcrum. Some examples of the second class levers, like the bottle opener, the nutcracker, the wheelbarrow, and the stapler. Let's check some photos. The nutcracker, we all notice that the resistance is between the fulcrum and the effort force. So the effort force is exerted here. This is the resistance, and this is the point at which the lever rotates. The bottle opener, the resistance is here, the effort force and the fulcrum. And this is the wheelbarrow. In the wheelbarrow, we have the load or the resistance in the middle between the fulcrum and the effort force. And this is the stapler. So these are examples of the second class levers. What do we have in the second class levers? The resistance between the effort force and the fulcrum. So if the question is, give reason, for example, the bottle opener is a second class lever, the answer will be why? Because it has the resistance between the effort force and the fulcrum. Now let's see the third class levers. I think you know now the third class levers. They should have what? Third class levers have the fulcrum, the effort force between the resistance and the fulcrum. The third class levers have the effort force between the resistance and the fulcrum. Some examples of the third class levers: the manual broom, the hockey bat, the tweezers, ice holders, or fishing tools. So all these are examples of the third class levers. How do we present a third class lever? A rigid bar, the effort force between the fulcrum and the resistance. Effort force between the fulcrum and the resistance. These are, this is the manual broom, sweet holder or ice holder, and the tweezers, the hockey bat. These are examples of third class levers.